In this video, we will look at properties of polynomial graphs. So first, let's look at maxima and minima. And remember, those are just the plural words for a maximum and a minimum. A function has a local maximum. The plural would be maxima. When there's a turning point whose y-coordinate is higher than all immediate surrounding y values on the graph. So something like that. You would have a local maximum at that point. A function has a local minimum, the plural would be minima, when there's a turning point whose y-coordinate is lower than all immediately surrounding y values on the graph. So something like that. For increasing and decreasing, a function is increasing when the graph is rising from left to right, so going like that. And a function is decreasing when the graph is falling from left to right, so sloping downward from left to right. For the degree of your function, the degree of a polynomial will always be as high as or higher than the number of zeros of the function, including multiplicity. So including multiplicity is important. If you haven't watched the video on multiplicity, then please do so that you know what that refers to. When we talk about the zeros, we're talking about the x-intercepts. So from a graph, you could count up how many x-intercepts there are, and you can figure out the multiplicity or possible multiplicity by seeing whether the graph bounces off of the x-axis or crosses through the x-axis. For the degree, you also have to look at the end behavior to determine if the degree is even or odd. So if you haven't watched the video on the end behavior, please look at that video. And a polynomial with n local extrema, remember the extrema are the maxima and the minima, must be degree n plus 1 or higher. So if you have n local extrema, that's maxima and minima combined, then your degree has to be at least 1 higher than the number of maxima or minima. Let's look at an example from Alex. All right, so given the graph, answer the following questions. Over which intervals is the function decreasing? At which x values does the function have a local minima? What is the sign of the function's leading coefficient? And which of the following is a possibility for the degree of the function? So first question is, over which intervals is the function decreasing? So I look at my graph. For decreasing, I'm looking for where the function is sloping downward. So here it's sloping downward. Then it goes upward. Then it goes downward again. And then upward again. And then downward again. Okay, so here where it's sloping downward, that is a place where the function is decreasing. Then it switches to increasing. Then it goes back to decreasing. Then it goes back to increasing. And then it ends out with a decreasing section. Okay, so decreasing, I know that this interval is going to be from negative infinity. And then I want to look at this x value right here. So it's decreasing up until this point. And I want to look at the x value. So negative infinity to -8 would be an interval where it's decreasing. Decreasing for this second interval, it's going from here where x is -6 down to this point where the x is -4. And then this last interval for decreasing starts out at x equals -2. And it doesn't stop decreasing. So it's going to go to x equals infinity. So to answer the question for where is it decreasing, I'm going to answer -infinity to -8. And remember, when you're doing interval notation, they're always x values. I'm going to use that union symbol. And the next one was -6 to -4. Let me double check that. Yep, -6 to -4. And then the last interval on which it's decreasing is from -2 to infinity. So notice this is interval notation. These are all x values. So these are x value intervals. No y values are involved here. All right, the next one says, at which x values does the function have local minima? Okay, so let me go ahead and erase all of this decreasing stuff. So now we're just looking for the local minima. So where is it going to have a low point? So a low point in the graph would be a minimum. So I have a minimum here. The ordered pair, if I look at the ordered pair, is -8. And then I'm not exactly sure what the y value is. So I don't know what that y value is, but I'm not actually being asked for the y value. Here's another minimum. And I can see the x is -4. And again, I'm not exactly sure what the y value is, but I'm not being asked for the y value, so that's okay. So those are the only two low points on the graph where all the y values surrounding them are higher. So the dips in your graph are your local minima. And our x values were -8 and -4. Okay, so minima at x equals -8 and x equals -4. All right, what is the sign of the function's leading coefficient? So this has nothing to do with the maxima or the minima or the increasing or decreasing. This just has to do with the end behavior. So I'm going to use the end behavior to figure this out. So if you missed the video where we talk about the end behavior of the graph of a polynomial, be sure to go back and watch that. So the end behavior, if I look at that graph, it is rising to the left and falling to the right. So I want to make a note of that. So it's rising to the left and falling to the right. And we have a little chart that tells us if a function is rising to the left and falling to the right, then it has to be an odd degree. This will come in with part D of this problem. So an odd degree, and it has to have a negative leading coefficient. And we get all of that just from the end behavior of the graph. Again, if you missed the video on end behavior of the polynomial graphs, please go back and watch that. All right, now the last part, which of the following is a possibility for the degree of the function? So we know it has to be odd, so it could either be 5, 7, or 9. And then we have that rule that if you have n local extrema, then the degree has to be n plus 1 or higher. So I look at the local extrema, there's 1, 2, 3, 4. So I have 4 local extrema. And so that tells me that it has to be degree 5 or higher. And the other thing I know is that it has to be an odd degree. And that's from the end behavior of the graph. So an odd degree, it has to be degree 5 or higher. So that would give me 5, 7, or 9 as possible degrees. So that's the possibility of the degree. So there's 2 things you have to look at. How many local extrema does it have? And is it odd degree or even degree? Meaning look at the end behavior of the graph.